Our last special segment in triangles will be the altitude, okay, the altitude of a triangle. And the altitude of a triangle, their intersection, is going to be called the orthocenter. So an altitude of a triangle, you may know this, you should know it, you may not be able to remember that why you knew this, but an altitude is usually the height of a triangle, or not usually, it is the height of a triangle. It is a perpendicular, so if you start at a vertex and draw a perpendicular to the opposite side. So an altitude is from the vertex and perpendicular to the opposite side. If we look at this problem here, let me erase this so you can see how this works. See how this vertex here, to draw a perpendicular, there is no side, right? The base ends. So if you extended out the base, that would be your perpendicular. Now, doing area, this here is the base. Only this is the base. So it'd be 1/2 A times B for the area. We're not going to really be doing that, but just to refresh your memory that the base is only the part of the triangle. So the altitude goes from a vertex and is perpendicular to the opposite side. And if the opposite side doesn't extend, you have to extend that side by yourself. Okay? So if we think about this, right? Hopefully if we're thinking about this and we're like, okay, well, in my mind, what am I going to need? Well, I'm going to need the slope of the opposite side. I'm going to need the slope of the opposite side. So let's do that here. We're going to draw the altitude from B. In order to draw the altitude from B, I'm going to need the slope of the opposite side. In this case, AC. So the slope of AC, let's see, this is -8, 3, and this is 8, 1, 2, 3, 4, 5. So this slope will be the change in y over the change in x. So it's 5 minus 3 over 8 minus -8, which is 2 over 16, which is 1/8. So if I have the slope of the opposite side, okay, if I have the slope of the opposite side, how am I going to know what's going to be perpendicular to that? Right, the negative reciprocal. So the perpendicular slope will be -8. Let's double check this 1/8. Up 1, 1, 2, 3, 4, 5, 6, 7, 8. Up 1, 1, 2, 3, 4, 5, 6, 7, 8. 1/8 is correct. So I'm going to draw the altitude. I'm going to start at the vertex B, and I'm going to use my -8. 1, 2, 3, 4, 5, 6, 7, 8. 1. 1, 2, 3, 4, 5, 6, 7, 8. 1. Always do 3 just in case one of the ones you did was incorrect. You're going to take your ruler to draw through those points. Okay? Now, this will be perpendicular. Because it is the altitude, it is perpendicular. Now, it asks us to find the equation of the altitude. Well, how do we find equations? How do we find equations? Yes, you need a slope. Well, the slope is -8, and we need a point. Well, the altitude comes from which point? B. So B is 1, 2, 3, 4, -4, 9. So I'm going to use point B and that. So to solve that, we've been doing a ton of these. 9 equals -8, -4, plus B, the y-intercept B. 9 is 32, plus B. B is -23. So my equation of the altitude is y equals -8x minus 23. Okay. We're going to need to remember how to do this, or need to know how to do this, so we can find the intersection of the altitudes by finding their equations and using a system. So again, to find or draw an altitude, you need the slope of the opposite side. That's number 1. Then get the perpendicular slope. right? First thing, find the slope. 2, get the perpendicular slope. Then you just apply it on here. There's 3, we just apply it. And then lastly, we find the equation 4. That is my order in which I'm going to do this. Now, the orthocenter will be the intersection of all 3 altitudes. Now, there's 3 different things that happen. If it's an acute triangle, it happens inside. If it's a right triangle, it happens at the right angle. That is where the intersection is. And an obtuse will be outside. Now this orthocenter is the point closest to each vertex. That means the total distance driven. So if I started here, here, and here, and drove to this point, or found the distance to this point, that is the least amount of driving. So if I was here, the least amount of miles driven to each of these vertices. If I'm here, the distance from there to there, there to there, there to there, is the shortest total distance from all 3 vertices. So this point here will be the shortest distance traveled from all 3 vertices. So let's find the orthocenter by graphing. We have L, K, J. Well, the easiest one is going to be right here. This is a horizontal, so we know that we're going to draw a vertical. Right? That's pretty easy. Don't have to worry too much about that. That's not like crushing us right there. We know how to do that. So now let's figure out the one from J. So from point J. That means we need the slope of KL. Change in Y, 1 minus 7, over the change in X, -3 minus 4, 1 minus 7. Oh, that's J. Didn't do that on purpose. That was dumb, Mr. Bracco. 7 minus 1, 4 minus 8, 6 over -4, -3/2. So my perpendicular slope will be 2/3 from J, 2/3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Okay. I'm going to take my straight edge. And I draw my line. Now I don't have to extend it all the way out here because I know my intersection is going to happen there. So my next one will be from L. So I need the slope of JK. Now, Y, change in Y is Y minus 7, -3 minus 4, -6 over -7 is 6/7. So my perpendicular is 7/6. From L, 7/6, -7/6, right? So I cannot go down and right, I'll run out of room. So instead of going down and right, I'm going to go up and left. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. There's no more room to draw my third. Let's take my straight edge, and let's hope it intersects. Let's hope it intersects the green and red lines. And it does. This here is called my orthocenter. And if I'm estimating, because it's not an exact point, I know it's going to be 1, 2, 3, 4. I know it's going to be 4, and I'm going to estimate 1, 2, 3, 4. 1, 2, 3, 4, 5. Maybe 5.5. Maybe a little bit more than 5.5. But if you said 5.5, I think I can live with that. Okay. So my orthocenter is about 4, 5.5. It's definitely 4 because it has to intersect at this equation here, x equals 4. Well, how would I go about finding that? Well, we can prove it algebraically. We have this line right here is x equals 4. Right? We have this line right here, color red. There's my x equals 4. Well, this one, what was the slope of this one here? This slope was 2/3. This slope is 2/3. And it's coming from the point 1, 2, 3, -3, 1. Now, you can already see what the y-intercept is going to be because you're applying it. But let's just go through the process anyway. Okay? 1 equals 2/3, -3 plus b, 1 equals -2 plus b equals 3. So my equation is y equals 2/3 x plus 3. And there's my plus 3. Now, you could stop right here, just use these two. You only need 2 equations. We can go and find the equation of this third one, but it's unnecessary. We already drew the graph and see the intersection. So, I have x is 4. I got to take this 4 and I plug it in to find the orthocenter. Y equals 2/3, 4 plus 3. Y equals 8/3 plus 9/3, right? Because I can't reduce anything. So y is 17/3, which is 5 2/3. We estimated 5.5. We said it's a little bit more than 5.5. That is a little bit more than 5.5. So it's perfect. So the orthocenter is 4, 5 2/3. You only need the 2 equations because you only need 2 equations to find a point of intersection. If this other one was all the way out here, you'd have to check your graphs, right? But they all intersect at the same spot. I have some for you to try. On these, just draw the altitude. I just want you to practice drawing altitudes on these 2 and then find your orthocenter. Okay? And then this, I really want you to do. I just want you to find out how is it actually used. Just find a reason for these things. All right, guys. Have a nice